Okay, so good morning, class. We are in our last module. So let us start today with that new chapter, that is earth pressure theories. Okay, so this is going to be your last module. So in this we have two subunits. One will be lateral earth pressure theory, and another one will be slope stability. Okay, so first we will take up the lateral earth pressure theory, then we will move forward from there. So all of you can see my PPT.
Yes, sir.
Okay. Okay, thank you. So let us take the cursor. Okay. So this is your third in your syllabus. It is a third module. Okay, so this is your, according to your syllabus, it is a unit 3, lateral earth pressure theories. So why you need to study this lateral earth pressure theory? That's first I will give some emphasis about this lateral earth pressure, why you should study this topic. So let us consider some soil. Okay, so if you pour some soil on the ground, so without any support, it can stand up to certain slope. Okay, so can you see this slope? So if you just put some, if you just pour some soil, so on its own it will attain some angle here. Okay, so can you see this angle? Okay, so this angle is called as angle of repose. Okay, so this angle is called as angle of repose. Okay, so without any support, without giving any support, it will achieve certain angle. Okay, so let us say some theta value. So that theta is called as angle of repose. Okay, suppose if you have in many circumstances, what will happen? You have to maintain this slope almost 90 degree. That means you don't have a luxury of a space to have this much length. Okay, so in many circumstances, what will happen? You have to retain the soil almost 90 degree. Okay, so for example, you see this is the backfill, this is the soil. Okay, so almost you see you have to retain this soil almost 90 degree, which is not possible on its own. Okay, so soil alone, it is not possible to maintain a 90 degree slope for the soil. Okay, so for that you have to construct some retaining walls. Okay, so this is the retaining wall. To retain this unstable soil. Okay, so to retain this unstable soil, you need a retaining wall. Okay, so to design this retaining wall, see, this retaining wall has to resist certain forces exerted by this soil. Okay, so this soil, what will happen? It will try to push this retaining wall. So it will try to push this retaining wall. So to design these retaining walls, you need how much pressure this soil is putting on this wall. Okay, so based on that pressure, you can design the cross section of this retaining wall. What should be the cross section area, and what should be the reinforcement, where tension is coming, where you have to put your reinforcement, everything you have to design. Okay, so to design these retaining walls, first before designing this retaining wall, I need to know how much pressure it is acting, this soil, whatever this soil is there, this soil, how much pressure it is acting on this retaining wall. Okay, so if it is a dry soil, only soil will exert a pressure. If it is a saturated soil, along with the soil, water also will exert a pressure. Suppose if you are building some structure here. Okay, suppose if you are building some structure here, then also this structure also will apply some pressure on this retaining wall. So all these how much pressure it is acting on this retaining wall, I have to know. Okay, so this chapter is all about to calculate this earth pressure. Okay, so earth pressure due to dry soil, earth pressure due to saturated soil, earth pressure due to your structures, some structure resting on your backfill. Okay, so those things we are going to study in this chapter. Okay, so here are some photographs of failures. So this is the retaining wall. Can you see this? This is the retaining wall. Okay, so this retaining wall is retaining the soil backside of this wall. Okay, so what happened? This happened in Malaysia. Okay, so this has taken from this website. It happened in Malaysia. What happened after a rainy season? After a heavy rain, what happened? This entire retaining wall failed. So the reason behind was the water table. Since due to rain, what happened? Some extra forces came on these walls because of some water or maybe some poor design of these earth pressures. Okay, due to that, you see this entire wall has collapsed. Okay, so this is the another view of the retaining wall. So without understanding the earth pressures, you can't design these retaining walls, right? So to effectively design these retaining walls, first and foremost thing, we should know the earth pressures. Okay, so this is one example from Malaysia of a failure of retaining walls. Okay, so this is another example from Singapore. Can you see here? See, this is the road. This is the road, and here some metro project was network was excavated here. Okay, so here you can see here, this is the before failure. Okay, so this is the before failure picture, and this is the after failure picture. Okay, so this is this happened. This is the Nicole Highway collapse on 24th April 2004. Wait a minute. Okay. So what was happening was here adjacent to this highway, some excavation was taking place. About 30-meter depth, the excavation was going on here. Okay, so because of the underground metro network they were placing here. So that's why here some excavation was going on. Okay, so to support this all the soil, what they did, they have built some retaining walls. Okay, here. So here some retaining wall they built. The depth of this excavation was 30 meter. So what happened was, here you see the collapse happened because of poor design of these retaining walls. The collapse happened. Can you see here all the collapse, and it killed about around 4 people have been killed, and 3 people were injured. So it's not only the human cost, even the financial burden on this contractor was huge. So he has to ultimately sell his all properties to pay back their loans. So in millions of dollars, the failure it costed him. So to design these all these retaining walls, the main inputs or main knowledge required is earth pressure theories. Okay, so a sound understanding of earth pressure theory can avoid this kind of failures. So this is the syllabus. So part A, in the part A, we will discuss about some this part A is all about earth pressure theory, and this part B is all about slope stability. I'll come to that slope stability in a while. Okay, so this will be part B and this will be your part A. Okay, so there are some links I have put here, some failure videos of these retaining walls. Okay, so in your free time, please watch these YouTube videos. Okay, so just I put some 4 links here. So those will tell you about these. They captured these retaining wall failures. So even I have some. I downloaded some videos. So before moving further, just I want to show you some retaining wall collapse here. So one happened in India and one happened in I think Turkey. Okay. So can you see here? These are the retaining walls. So this is a one kind of retaining wall. This is the one kind of retaining wall. These are called as diaphragm wall. Okay, so this happened in India. Okay, so adjacent to these a huge residential complex, they were constructing one more multi-story building here. Okay, so that's why. So when for foundation purpose, if you excavate all this soil, what you have to support these structures. Okay, so if you remove the soil from this side, what will happen? These structures will collapse, right? So to avoid that, you have to build these retaining wall structures. Okay, so to avoid any cracks or any failure of these structures. Okay, so you see because of improper design of these retaining walls, can you see these how much leaning is happening here on these multi-story buildings? So just I will fast forward this video so that we can save some time. So ultimately, you see this here, the initiation of failure has started here. Okay, so this is the can you see here some soil is falling apart from here. So these are all retaining wall structures. See, entirely ultimately, see, entire thing has been collapsed here. And these all residential buildings will be under danger. Almost nobody is ready to occupy these, because almost it would have given a lot of severe cracks in the structure. Okay, so from the outside they may look like some intact with a certain sway, but with a severe cracks. Okay, so nobody is going to dwell in these kinds of structure. Okay, so huge loss for the contractor and even the owner. Okay, so this happened in India. So they have one more failures. Okay, this is another kind of a retaining wall. So again, in the retaining wall, different types of retaining walls are there. Okay, so that we are not going to discuss in this class, because that itself is a big topic. Different types of retaining wall. Okay, so you just understand this. This is a one kind of retaining wall. So this happened in Turkey. Okay, so can you see here the entire retaining wall is collapsed. Okay, so to properly design these retaining walls, I need to know how much pressure this soil is exerting on these retaining walls, right? So that's what we are going to study in this chapter. Okay, so I have put some more videos, so in your free time please watch them, so that you will get some motivation why to study this chapter. Okay, so let us start with the introduction. Imagine some swimming pool. We construct a wall along the perimeter of the pool to contain the water. Okay, so just to give some analogy between the retaining wall and this pool. See, why we need to construct these walls? We have to retain the water in this pool, right? So to retain this pool, we are building these walls. Okay, so if you always this water will exert pressure all along the direction. Equally it will apply, equally the pressure will be applied. Okay, suppose if I take at this level, suppose this is the wall and this is the retaining this is the swimming pool cross section, you assume it. Okay, so this is the wall of the swimming pool, and here we are containing the water. Okay, so what will happen? This water will, whatever this vertical stress, what will be the vertical stress at this level? Suppose at this level at a depth of h1 I will call. Okay, so your sigma vertical is equal to sigma horizontal. Okay, so whatever vertical pressure is there is almost same almost equal or exactly equal to your horizontal stress. Okay, so your horizontal stress is nothing but whatever vertical stress is there. What is the vertical stress here? Vertical stress is nothing but gamma W unit weight of water into H1. Unit weight of water into H1 will be my vertical stress. Okay, so this is equal to your horizontal stress. So that's why, see, this water will always, it will your vertical stress and horizontal stress will be same here. Okay, so further at any height the water vertical and horizontal stresses is equal. That's what I explained here. Okay, so your vertical stress is equal to horizontal stress, whereas in soil this is not same. Whatever your vertical stress is there now, this vertical stress is not equal to horizontal stress. Suppose now instead of water I will retain the soil here. If I retain the soil, suppose at this level I want to see what is the stresses acting on the soil element at this level. So this is my H1. Okay, so my sigma vertical stress is equal to whatever unit weight of soil is there, unit weight of soil into the depth or height. But your sigma H, that is horizontal stress, is not equal to vertical stress in case of soil. So your vertical stress is not equal to horizontal stress in case of soil. But whereas if you retain the water here, your vertical stress is equal to the horizontal stress. Okay, that's why if you see some these big sportsmen, like maybe some very big football players, for example, if you take Cristiano Ronaldo. Okay, so what they will do, they usually will, if you carefully, if you observe them many times in the YouTube video, you will see these big sports persons. They will always do some exercises in the bathtub or in a swimming pool. Okay, so why? Because see, whenever we are doing some exercise, there is always a possibility of some injury, right? So if you do exercise in these kinds of a water bath or a swimming pool, there will be almost negligible chances that you will get some injuries. Okay, so because all your knee joints will be there, so all those joints will be subjected to same stress all along. So if your joints are stressed by same equal forces, then there is a very less chance that you will get injured. So that's why if you see a big these sports persons, they will do some exercises in the swimming pools. Okay, just to avoid any injury while doing these exercises. So the reason behind was the pressure, the soil, the water will exert equal pressures all along the directions. Okay, you take any direction, you take Z direction, you take any horizontal Z1 from vertical, from bottom, from left, right, all the stresses will be same here in the water. Okay, so that's why there is a very less chance that you will get injured if you do some exercises in the swimming pools. Okay, so always if you in gym and all, if you do some exercises, there is a possibility that some knee jerk may happen or some injury may happen. But if you do the exercises in water, there will not be any chance that you get injured. So that's why these all big sportsmen, they will do the exercises in the water. Okay, so this is the about the swimming pool. Okay, so like what we take away from this slide is your vertical stress and horizontal stress are equal, sigma H. Sigma V is equal to sigma H. But this condition will not be holds good for the soils, because soil is a granular material. Okay, so these granular material, whatever vertical stress is not equal to horizontal stress. Okay, so what are the different types of retaining walls? Just in my previous video, I have shown different types of these retaining walls. No, so what will happen in geotechnical engineering? It is often necessary to prevent a lateral soil movement. Okay, so if you see these kinds of retaining wall is called as cantilever retaining wall. Okay, so usually in the hilly roads, you will come across these kinds of retaining walls. Suppose if you have a hill like this, gentle slope you have a hill like this, what will happen if you build a road here? What you have to do? You have to, suppose this is my road cross section and this is your hill. Okay, so you have to cut some material. You have to cut this material, and this material you have to fill it here. Okay, so that I will get some wide road here. Some wide road. So what will happen once you cut this material? Then this entire soil above this whatever this cut portion is there, that will become unstable. That will become unstable, and it will try to flow down like this. Okay, so to arrest that, you have to build a retaining walls. You have to build a retaining walls like that. Okay, so if you have traveled in this Pune-Mumbai roads highway, so there you may see a lot of these retaining walls. So all along the hill, whatever this upper portion is there, this to arrest or to avoid this soil movement down the road, we will build these retaining walls. Okay, so this is one example of a cantilever retaining wall. Okay, and then see this braced excavation. Okay, so braced excavation, you see, I shown one in my previous example, this Nicolet Highway in Singapore. Okay, so they were like for metro and all, you have to for metro station or some metro rail project, you have to do, you will come across these kinds of braced excavation. Okay, and third example is these anchored sheet piles. So these anchored sheet piles are nothing but so these usually come across in the offshore structures. So what will happen here? You have to this is the sheet pile. Okay, so once you cut the soil, this soil will try to move like this. So to arrest that, you have to build this sheet pile wall. So this sheet pile wall will be subjected to this lateral movement of the soil. This is also one kind of a retaining wall. So another kind of retaining wall is this gravity retaining wall. Okay, so here it is a cantilever retaining wall. Here it's a gravity retaining wall. That means whatever this movement of the soil is there now, that entirely will be registered by a shear weight of this almost the dead weight of this gravity retaining wall. Okay, so here along with here in the cantilever retaining wall, we will be having some steel reinforcement will be there here. Some reinforcement will be there. So, but in the gravity retaining wall, there will not be any reinforcements. Okay, so the movement of this soil will be registered by this weight of this retaining wall. Okay, so another example is the soil nailing. So this whatever unstable soil is there, this can be retained by drilling these soil lanes. Okay, so even these kinds of soil nailing usually will be, you can see in these hilly regions. And another kind of retaining wall is the reinforced earth wall. Reinforced earth wall. So in the in Bijapur itself, you can see many reinforced earth wall structures. Okay, for example, if you go to this Sindhgi Naka, can you all of you know aware about this Sindhgi? While going from Bijapur, if you go to after the Gol Gumbaz, once you reach the NH, no, so there is a ROB they constructing, that is a road over bridge. So for the underpass will be there. Okay, so for those underpass and all, to retain the soil, these kinds of earth retaining structures will be, reinforced earth wall will be used. Okay, so this is also one example of this retaining wall. Okay, so even if you go towards this what do you call that, railway track is there, no, there also they were building this these reinforced earth soil, reinforced earth wall. This is also one kind of a retaining wall. This is the soil, and these are the some what do you call these facing material will be there, and these will be geosynthetics. Okay, so these geosynthetic will be there. They will along with, they will resist the movement of this soil. This, whatever this movement will be there, no, this movement will be registered by the tensile strength of these reinforced these geosynthetics. Okay, so what is a retaining wall? See, almost what is the aim? What is the main aim of this retaining wall? The aim of earth retaining wall or earth retaining structure is to create a space where space is at premium. That means if you wherever, see, in the almost all in urban settings, the space is very costly. Okay, the space or the whatever the space is there, that will be very costly. Okay, so you have to effectively use that space. Okay, so one example is here, you see. So this is the slope, earth slope, and here some structure is there. Here you have some road. So if you are not constructing any earth retaining structure, then what you have to do? You have to give a very gentle slope. You should provide here. Then only this soil will not move. Okay, if you provide the gentle slope. If you want to use some effectively, if you want to use some space here, okay, so then you have to provide a very steep slope. You have to provide. You have to provide a very steep slope. Once you provide steep slope, what will happen? The soil will start move like this. Soil will start move. So to avoid that, you have to build these retaining structures. Can you see this retaining structure? So this is the retaining structure. This is cantilever retaining structure. Okay. So once you build the retaining structure, then you have to provide. You can provide almost 90-degree slope. You need not to provide this gentle slope. Almost 90-degree cut you can make. Almost 90-degree. Can you see here? Almost 90-degree slope. So, but once you provide this 90-degree slope, what will happen? The soil will start moving here. So to avoid that, you have to build a retaining wall. So this is the retaining wall example. So what is the function of retaining structure? Often need to provide a temporary and a permanent space for the underground parking or subway stations. Okay, so the retaining structures will retain the soil in place when natural tendency of the soil would be to slide due to self-weight or existing surcharge load. Okay, so this will act like an existing surcharge load. Okay, so under the existing surcharge load and always soil try to attain these equilibrium, right? So that's why this soil will try to slide. So to avoid that, you have to build this retaining structures. So to design these retaining structure, I need to know with how much force it is sliding. Okay, that means earth pressure theories we have to study. Okay, so here are some examples of the retaining wall. Okay, so can you see here? This is the excavation. Here your new project is coming up. So once you are building some new structure, so it is your responsibility to make sure that no damages are occurred in these existing structures. Okay, so whatever these existing structures are there now. So the safety of these existing structures is on your shoulder. So if any small cracks appears in these structures, then these owners can go to the court and they can stop your entire project. So once the project is halted, means so in the industry the time means money. So yeah, see, usually these litigation in the court, it will prolong like years together. Once the years together, if the structure is if your project is halted, then you will face a huge loss. So that's why the safety of these structures will be on your shoulder. So that's why to avoid any damage to these existing structures, you need to build these retaining walls. So this is a diaphragm wall they can call. Okay, so So these are all retaining walls. So to design these retaining walls, you need a earth pressure theory. That means how much pressure is acting, how much pressure is coming on these structures. That you should know. Then only you can design these retaining walls. This is one example. And another example is the sheet pile walls. Okay, so the sheet pile wall also the same. That the main aim is same. Okay, so if you want to do some excavation here, then you have to the safety of these structures. You should ensure all these structures, whatever existing structures are there, their safety must be ensured. How you will ensure that? By constructing these sheet pile walls or some sheet pile wall. It is also a kind of retaining wall. Okay. Okay. So again, here also these sheet pile walls. Okay, so these are also sheet pile walls. Now, once you drive these sheet pile walls, then you can excavate the soil here. So by doing that, you will avoid any surrounding structures damage that can be avoided. Okay, so here, so you see these are the sheet pile walls. Again, these are sheet pile walls. Almost if you in your if you have visited this Bangalore metro, this near what do you call that, Majestic, near Majestic. Now I think the underground station has been built. Almost it is over. Now you will not be able to see these structures. Okay, so when I was a student, when we were going there, so I used to see these all excavation work. So they were all supported by these kinds of retaining walls. Okay. Again, this is another kind of retaining wall. Okay, so these are called as secant board pile wall. So once you do these kinds of secant board pile, okay, can you see this? This is the completed secant board pile walls. So you can see this is called as secant board pile walls. Okay, so these are also a kind of retaining walls. Soil nailing. I talked about. So I have shown some pictures on soil nailing. Okay, so this is also a kind of retaining wall. Okay, so to give some extra support, what we will do? We'll drill a hole here, and we will grout these. We will insert some nails, and then we will grout that place. Okay, so that this entire retaining wall will get more what do you call more factor of safety against any lateral movement of the soil. Okay, so another example of a retaining wall is gabion walls. Okay, so usually these gabion walls we will use in these banks of the to avoid any erosion during monsoon. What will happen? This river will overflow here. Okay, so to avoid any damage to these infrastructures, we have to build some gabion walls. Okay, so these gabion walls will avoid. This is also a kind of retaining walls. This is also a kind of retaining wall because it is retaining the soil on this side. Whatever the soil present on this side, no, this soil is retained by these gabion walls. Again, this is another example of a diaphragm wall. Okay, so usually these diaphragm walls we will use in metro stations, underground metro stations. This is also a kind of a retaining wall. So another example of a retaining wall is called as crib walls. So crib wall means like these kinds of RCC framework will be there. In that, whatever space is there, we will put some granular materials. Okay, so these granular materials will be put. Okay, so by sheer weight of this soil along with these concrete blocks, it will avoid any these another view of a crib wall. This is another view of the crib wall. Okay, so on the one side it is retaining soil. Even you can grow some vegetation here. Okay, so you can grow some plants here. Okay, so it will give some good aesthetic view. So this is another example of a retaining wall. Okay, so the reinforced earth wall, what I told you, in the near to this Sindhgi Naka, you can see these kinds of retaining reinforced earth wall. Okay. Okay, here this is also a reinforced earth wall. Recently it failed. Okay, so in the Turkey, just it is in March 26, 2021. Recently the failure happened in these. This is one example of this this reinforced earth soil. So even this reinforced earth soil is also a kind of a retaining wall. Okay. Soil which is resting behind the retaining wall exert a lateral pressure or a force on the vertical face of this retaining wall, which is known as lateral earth pressure. Okay, so here, see, this is the whatever soil we are placing here, no, like some embankment. Okay, so this is like some embankment. Okay, so here whatever soil is there, that will try to slide down because of a narrow or very small slope you are providing here for these kinds of embankments. So design of retaining structure should be such that it is able to bear this. It should able to bear the earth pressure, and hence we should know the magnitude and line of action of these lateral earth pressure. Okay, so that's what I explained in my starting slides itself. Okay, so these are all retaining walls. To design the retaining wall, the first and foremost input is the lateral earth pressure. So this is the lateral earth pressure. So if estimation is not made properly, there may be failure in the retaining walls, thus failing the only purpose of retaining wall. The only purpose of retaining wall is what? The sole and whole purpose of this retaining wall is to retain the soil on one side. If that purpose is not meant, then you are not doing the purpose is not served here. Okay. So, for example, is here. Can you see this expressway? This expressway is collapsed recently in 2021. Okay, so again, different types of retaining walls. So here, different types of retaining wall and how they will move. You see, these are the different retaining structures and retaining structures with their mode of deformation. Okay, so how they will deform. So if you first one is the retaining wall, or this may be a gravity retaining wall, or it may be some cantilever retaining wall. Okay, so what is the mode of deflection? The mode of deflection is here soil will try to push this wall. Okay, so here the soil is trying to push here. Okay, the mode of deflection is the mode of deflection of this retaining wall on this side. Okay, away from the backfill. Okay, so whatever backfill is there, away from that backfill, the wall is trying to move here. Okay, once that wall is moving, trying to move in this direction, so whatever soil is present at the toe of this retaining wall will try to push here. Okay, so this soil will be pushed, and this in terms of wall movement, I will tell. Okay, so here the wall is moving away from the soil, away from the backfill on this side, and here the wall is moving towards the soil here. Okay, so here soil is there, it is moving towards the soil. Okay, so here you see the example in these bracing cuts. Okay, so this is an example of a bracing cuts. Okay, so here also the whatever retained soil is there, no, this retained soil is trying to push this wall in this direction. Okay, so the wall is trying to move like this. Okay, so this is the mode of deformation in the bracing cuts. Okay, okay. So another example is, you see this bridge abutments. Okay, so this is the bridge. here a river is flowing like this, and here all the bridge piers will come. Okay, so once at the end of this river, here the road will start, right? So just if you coming from the land side here, okay, so the first whatever pier will be there, no, that pier is supported on one side, it is supported by soil here. Okay, soil will be here. Okay, so this is called as a bridge abutments. Okay, so this bridge abutment, what will happen, the soil will try to push like this, but whatever your bridge deck will be there, no, this bridge deck will try to avoid this. Okay, so this bridge deck will try to move this soil on this direction. Okay, that's why you see, so here it will be fixed, here it will be fixed, only the moment on the wall is moving away from the backfill at the bottom side. And another example is these anchored sheet pile walls. So here anchored sheet pile wall, it is trying to pull this wall on the upper side. It is, see here, some anchoring will be there. Okay, it will try to push these anchor sheet pile wall. Once you push this will move like this, right? So this is the deformation mode. And another example, you see this twin retaining walls. If you have a hill on the both side, so here also hill is there, here also hill is there, here and here, and in between two hills your road is going here. Okay, so that means you have to retain the soil on this side as well as on this side. So what is the deformation shape? It is moving, the deformation shape of these retaining walls will be like this. Okay. Okay, so till now whatever I discussed is just the introduction. Okay, so nothing is coming from the exam point of view. You don't have to worry about all these things. Okay, so this is just to give you the emphasis on why you should study these retaining structures. Okay, so to design all these kinds of structures, I need to know the earth pressure theory. Okay, that's what the main takeaway from this lecture. Okay, so whenever the exam point of view will encounter, I will let you know. Okay, so these are not just the introduction part. So don't have to bother about much about these whatever till now we have discussed. Okay. So in the next class, what I will do, I will start actual portion from the actual portion of your syllabus. Okay, till now we have seen only a small introduction about the retaining walls. Okay, so if you have any doubts, please ask me. Okay, so in the tomorrow's class, actual syllabus will start from tomorrow's lecture. Any doubts regarding today's lecture? I'll stop the recording here. Stop recording.